Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely fantastic day. Here's what we're going to do. Today we're going to go ahead and finish up the Huffman tree stuff for basic Huffman trees. Now, there's a lot of stuff we could do, but the stuff we're going to do should be able to be done by the end of today. Then what I want to do is take a step back and start working on some stuff for my next video. Novelis, hey, what's up? And the next video, I realized I have been saying for a while that I wanted to be the Huffman tree things, but something happened with the last video, and that was that it was posted again on R Math. And the thing is, though I definitely appreciate the fact that everyone likes liked the last video enough that they wanted to post this video too. Let me see, GLSL Sandbox, open link. What do we have? Oh yeah, I saw this one. I think it's pretty cool. Everyone ends up being way better at this kind of stuff than I am. But yeah, so I wanted to make another video next time, not on the Huffman tree stuff, but actually on something that brings the last two videos together, which would be the video on Monte Carlo and the video on eigenvectors. And so I wanted to do one on determinants real quick. So the determinant's actually really cool to visualize and stuff like that. So I just wanted to spend maybe a day or two getting all of the necessary graphics for that, and then get back to working on the Huffman tree stuff. So, and kind of the reason I want to do this, guys, is because I'm not far enough along with the dynamic Huffman stuff to really start going forward with that. So I need a little project on the side to figure out all of this other stuff first. So I apologize for that, guys, but that's about as far as I can get there. However, that said, I definitely want to get started with the dynamic Huffman stuff, and I think it's going to turn into some really cool looking graphics when we're done. So let's go ahead and open up Zernal and get started. I figured I'd go ahead and let you guys know what it was that I was planning to do. And I apologize again if it's a little bit different than what I have been saying up to this point. It's just, I've been thinking about what we should do for videos, and I really think this next one needs to be something more mathy, and then we'll get back to some more algorithms and stuff like that a little bit later. In the end, it doesn't really matter. I mean, the thing is, I have to grow my channel kind of slowly because I've got work and all this other stuff. So the way I see it is I'm just going to move at whatever pace I can. No matter what pace I move at, it's going to be faster than the pace I was moving at before. Besides, we're on Twitch now, not YouTube. So the way I see it is this content isn't going to be changing that much. We're still going to be doing different algorithms every day, learning new things. That's kind of the point, right? So it's not going to change that much. Anyway, let's go ahead and get started. Today we are continuing working on the Huffman encoding scheme. If you have not been here up to this point, Huffman encoding is the idea that we can compress a, I guess, string of letters into a very small number of bits. So Huffman encoding. We take a string and we output bits. And of course, the idea is that this is an optimal number of bits. Now, how do we know it's optimal? Well, we know it's optimal because Huffman encoding has proven to be optimal. Now, when I say optimal, what do I mean? Well, let's say you have this string. Okay, you have a lot of A's here. If A is 0, 1, B is 1, 0, and C is 0, 0, sure, this is a code that will work. However, we're wasting a lot of space here because we use so many A's. If A were instead 1, B were instead 0, 1, and C were 0, 0, then this could be encoded with many fewer digits. For example, if this were, let's say, scheme A and scheme B, or maybe 1 and 2. Yeah, how about alpha and beta? Okay, so using scheme alpha, this is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 0, 0. With scheme beta, it's 1, 1, 1, 1, 1, 1, 1. Then we have 0, 1, 0, 1, 0, 0. Okay, so we save, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We save 7 bits. That's a lot of bits. So that's kind of the idea, right? We're basically trying to encode this data in such a way that is optimal. Now, there are more optimal strategies, which we'll talk about later, dealing with dynamic encoding. Now, there are plenty of ways to do that. We could do it with dynamic Huffman encoding, which is what we'll cover first, but we could also do it with a whole bunch of other dynamic encoding techniques, which we can cover later if necessary. But that's kind of the idea, right? We want to go through all these different encoding schemes. Okay, new page before. How do we do Huffman encoding? Well, it's not so bad. So in the previous example, let's say we have A with a frequency of 70%, B with a frequency of 10%, C with a frequency of 10%, and D with a frequency of 10%. All we do is add up the two lowest percentages. So now it's 20%. And create a new node that is a sum of the two that we just added together. This would now be 30%. And then we add this one together for 100%. Then what we do is we go down the line and we say this is a 1, this is a 0. This is a 1, 0, 1, 0, and we read backwards. So we say A is now going to be just everything along here, which is 1. B is going to be 0, 1. C is going to be 0, 0, 1. And D is going to be 0, 0, 0. And there you have it, your optimal bit encoding scheme. And that's kind of the idea, right? We go through, we have our bits, we encode them, we encode our digits, and everything's fine. Up to this point, we have properly encoded a Huffman tree. We have properly done the encoding and decoding of a pretty long string with what's known as 2-pass Huffman encoding. The idea here is that we go through, one second. The idea here is that if we have a string of letters, A, B, B, C, C, D, we go through it first to find the frequency. So let's see, let's do DD. This means that A has a frequency of 0.25, B has a frequency of 0.25, C has a frequency of 0.25, and D has a frequency of 0.25. And obviously if we add these guys together, we get 1. And then 1, 0, 1, 0, 1, 0. We have A as 1, 1, B as 1, 0, C as 0, 1, and D as 0, 0. And there you have it. That is our encoding scheme. And the idea is that we went through the string twice. So the first time we went through to find the frequency, that's the first pass, and the second pass was the pass where we actually did the encoding. Now, there are, again, more efficient schemes we can use. These are one-pass Huffman encoding schemes, and these are dynamic, in which we'll talk about maybe a little bit later, either this week or next week. Okay, now what do we need to talk about? Let's see, we have 2-pass Huffman encoding, so this is what we've done so far. Now let's talk about what we screwed up with. What we were trying to do was visualize this system, because again, when we start doing the dynamic encoding, or at least I would like a way to more easily understand what the dynamic encoding is actually doing. So, what does that mean? Well, we went through, let's see, CD projects. Oh, come on. Projects, Simulaos. What do I want? Huffman. Okay, so we went through and we did this. We did Mirage. Let's do frames, animation.gif. Okay, so this is the GIF that we have. You'll see all of the external nodes being drawn, and then you see something screwing up, big time. So what do I mean by that? Well, we have all the external nodes being drawn. That's exactly what we want to see, right there. However, the external nodes are being drawn in the incorrect places. I can tell you that because the lines that are being drawn from each node are also being drawn in the incorrect places. So we have this point where we have all the nodes being drawn, we have the tree being drawn, however, we're not drawing the correct tree, nor are we drawing the correct nodes. Rather, we are drawing the correct tree, but I think the nodes are in the wrong spot. So we have to go through and redraw the nodes such that they're in the appropriate place. One last note though, guys, I think we're getting pretty good at doing animations. I really am. This looks pretty good. I mean, not like awesome, but it looks pretty good. And I could imagine if we drew everything, gave it enough time to draw each of the lines separately, I could imagine this could turn out pretty good. So let's go ahead and get the dots in the right spot, and then we're going to go through and fix the Y position so they add upwards instead of downward, and then we'll see what we need to do from there. We can add internal nodes. That's not that big of a deal. We'll see what makes the most physically intuitive sense from there. One thing I'd like to do is add the letters in to each of the little dots here. So every time we draw a new dot, we also put a new character in the position of the new dot. Sorry for the yawn, guys. And let's see how this goes. Yeah. Okay, so I'm going to go ahead and get a quick sip of water, and then we can go ahead and get started. Again, if you have any questions, comments, concerns, let me know, and we can totally talk about that as soon as I see them in chat. Good. Okay. Okay, so let's go ahead and open up CD Projekt Simulators Huffman, and let's open up Huffman visualization.cpp. Huffman visualization.cpp. Okay, so what do we need to do? Well, here's the thing. When we were originally drawing the points in the draw tree function, first thing I'm going to do is I'm going to change this from draw tree to draw external. So let me go through and let's fix that. So here we're going to do, where is it, :s, draw tree to draw external. Okay, and the reason I did that is just because I called the internal nodes draw internal. Plus, it's a good way to go ahead and immediately end up at this function here. Okay, so what did we do? Well, what we did last time is we took the maximum number of bits, right? And then we went through and we, how do I put this? So we went through and found the maximum number of bits in each string in the map that we created for the Huffman tree. In other words, B is, let's say, 001, C is 001, and those both have length 3, but some could have presumably length 7 or something like that. So we found the max number, the max length of the string, and said, okay, this is somehow related to their weight. And this is our big flaw here. The code length does not directly correspond to the code weight. Meanwhile, with the draw internal, which is where we're drawing all of these extra lines that connect together, let's see, find X position, draw internal, we said, okay, well, the maximum bit, let's see here, is going to be, we're going to add them all together. However, this is still incorrect. What we should do, and this is something that I guess I'll get done right now, but what we should do is we should go down and add all of the weights together. Oh, we have the weight of the root node, don't we? Good, good. Okay, so let's go here. We are reading in the root node. Yes, we are. Good. Okay, so let's go here. Let's go ahead and remove this guy right here. And then every time we use max bit, let's see, instead of using that, we're going to use final tree, pointing to node, root, sorry about that, pointing to weight. Good. Okay, we'll do the same thing for all of these guys right here. And the reason we want to do it this way is because the weight of the root node should be, unless we're completely wrong here, the weight of the root node should be equivalent to the total weight in the system. So let me see here. Do we, at any point, regenerated nodes pop? Yes, good. So we keep this guy just fine. So let's go ahead and do this again. Final tree, pointing to root, pointing to Oh, oops. Screwed that one up, didn't I? Wait. Okay, let's go here. Wait. And this has to be final tree. Okay. Now the last one, let's see, max weight. Where is... Oh, okay, I see what I did. My bad. So here we do final tree. 1 second. There. And I think that's going to be it for the max bits. Yep, okay, that looks like it's it for the max bits. For the draw internal. Oh, okay, let's go ahead and remove this. Okay, let's make it one more time, and I'm going to show you what it looks like when it runs. So make... Oh, never mind, I'm not going to show you what it looks like when it runs, because I screwed something up big time. We're not pointing to root here. We are pulling root out and then pointing to weight. My bad, I forgot final tree is a struct, not a pointer. Make. Okay, so here's what we got. Let's go up here. So what we did is we took the phrase, Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, Jill came tumbling after. And then what we do is we go through and encode them all. You'll see that the shortest one is a space. Then probably one of the longest ones is probably the new line right here. Divided by that makes it a value between 0 and 1. Yes, that's exactly what it does. And then we multiply it by a scale. So then after we encode that phrase, what we do then is we go through and change it into this guy, which is a series of 1s and 0s, and then we decode the phrase with the same map that we had before. Again, this can be more efficient with a dynamic Huffman encoding scheme, but we're not there yet. We have a little bit of time before we get there. Okay, then we basically go through, plot all the positions. Good. And now let's go into the animation one more time and let's see how it looks. So here's all these positions, and let's see what happens. It doesn't look that much different. It looks almost the same. This could be because... Well, here, let's go into the images. So let's go into Mirage. What do I want to do here? I want to do Mirage Image. Oh, come on. What do I want? Frames, image 0, 0, 0, 0, 0. Whatever, that works too. Okay, so here's all of the, 1 second. Here's all of the dots appearing. And then here's all of these guys appearing. Yeah, it looks almost the same, which is probably for the best. Okay. So let's go through and let's continue working on this. Okay. So I assume this is more correct than it was before. Now we have to draw internal. So we said no parent weight, node 1 weight plus node 2 weight. What am I doing here? For the draw internal, we do read in the Huffman tree, which is good. That's what we want to do. Where do I use max bit and draw? Oh, draw external. I'm sorry about that, guys. Draw external, we do also read in the Huffman tree, which is exactly what we want to see. So instead of using max bit, we're going to do the same thing we did before, except this time, let's see, we need to read in the weights of each individual starting node. And that's not necessarily the easiest thing to do. So let's see, we have temp position Y. Let's see, we're going to go through each of the keys. Okay. So how about this? We go through each of the keys. Let's also create a map. Maybe the height of the lines should change. Should be the same and just change the angle. Let me see. Mirage, animation. 1 second. Frames. Animation.gif. So you're saying start them all at the same position? We can do it that way, but first let me try it this way that I want to try now, and then we'll go through and see what it looks like after that. Let me think. If we start them all at the same position, then we do what, hey iCare, then we do what I kind of do on my own. But I kind of wanted to make this look as tree-like as possible for, well, other reasons entirely. Now, let me think. Yeah, good. They are all appropriately positioned in X. I know that. So let's go here. We have the Huffman tree being read in. Now, I want to read in one more thing, and that's going to be a map between each of the characters and the character weight. So where do we do this? We do animate line. Let's see. Let me go up to main. So we do Huffman tree, final tree is going to be a 2-pass Huffman between all of these guys. So here's what I want to do. In the Huffman tree, I want to add in an additional map. So let's go here, right and quit, and let me go into vi Huffman.h. Okay, now let's go down here, and where is Huffman tree? Here it is. I want the following: std unordered map of character and std. Oh, I'm sorry. Double weight. And here's what I'm going to say. It's going to be called weight map, because I'm totally original here. Okay, so we have that. Let's go here and go into vi Huffman.cpp. And now let's go into the 2-pass Huffman. Here it is there. Next is down here. Okay, so what we need to do now is key weights is going to be equal to phrase. Let's see, what did I call key weights? Key weights is phrase I, character double. Actually, this key weights is exactly what I want. Final tree.bitmap. So let's change key weights here into what I just called it before, which was final tree. Wow, screwed that one up big time, didn't I? How did I get there? So let's go 2-pass. Here we are there. Let's go down here. That's fine. 2-pass Huffman. And here's what we're going to call it. We're going to say final tree.phrase. So we don't have to get that anymore. We go here. And now what we say is instead of key weights. Wait a minute. What did it look like before? Let's go ahead and quit. Let's open it up before. Let's go down to 2-pass Huffman. 1 second. 2-pass. Where are we? There we are. 2-pass Huffman. So we create the map. Then we say if key weights a phrase of I. Let's see. Oh, okay. If it exists. Fair enough. Okay. So what did we call the map? I think we called it weight map, if I'm not mistaken. So we can go ahead and get rid of these lines here. And we can say if final tree.weight map. Then we go down here and say final tree.weight map. One second. Good. And now we just keep doing this for the rest of them. So let's go down here and say final tree.weight map. Okay. Now let's see if I have any more of the weight. Create nodes, and I want final tree.weight map. Weight map. Let's see, anything else? No, that looks like it's about it. So here's what I want to do. I want to go over here, and I want to make it real quick just to make sure I didn't screw anything up. Looks like I did. So let's see what we got here. Template argument, double weight. Argument 2 is invalid. Fair enough. So let's go into Huffman.h. Okay, down to the bottom. And let's see, where did we put this? This should not be double weight. We should just say it's a double. And then over here, let's make it. And it should make just fine. Okay, does exactly the same thing as last time. Let's go ahead and write and quit. Now let's go into Huffman visualization.cpp. Okay, so now what we need to do is go down to the draw internal, which is what we do to draw the internal nodes. And, yep, good. Draw internal. Yes, this is what I want. So now what we're going to do, draw external. Sorry about that. Draw external is what I wanted. We're drawing the external nodes. So now we don't need any of this max bit nonsense anymore. That's gone. Now what do? We go through here. We say temp position Y divided by max bit. Okay, so in this case, the max bit isn't going to be this, and the key second size is not going to be that. So let's go through and fix this up. So the temp position Y is going to be equal to Let me see. We're in a key. Key first is a character. So let's do the following. We're going to say, I think we read in tree as just tree. We do. So we're going to say tree dot weight map of the key dot first. Okay, so this should be our double value of the weight divided by, what do we do here? Let's do tree dot root pointing to weight. And now, do I use the max bit anywhere else? There, but that's okay. Good, it's not used at all. Let's go and write this and let's make it and see how we break it. Okay, looks like everything's going okay. So let's go ahead and look at the animation in just a second, once it pops up. Okay, so now we're gonna do animation.gif. Let's see what we got. Oh, look at that. They are appearing in the appropriate positions. Fantastic. This is exactly what I wanted to see. And now they're being drawn together. Now, there is a bit of a problem here in that the leaves are quite big and the tree is being drawn, well, the leaves are being written over themselves, right? So let's go through and let's see if we can figure out a better way to do this. So what we want to do is basically, the closer we are to 1, the shorter we want the branches to be. Does that make sense? So we want them to be more spread out in X and more spread out in Y. Now we can do this in a number of ways. So let's go through, and the first thing we want to do, or rather, the first thing we want to do is commit this to GitHub. So let's go ahead and do a git commit Huffman visualization .cpp. Okay, now we're going to say internal nodes, external nodes are drawn. Okay, good. Do git push origin master. Okay, so now this update, what we've just done right here, is available on github.com. So feel free to go to my channel, which I guess I'll do right now. Here's my channel. Scroll down a little bit to info, down to the very bottom to my GitHub account right here. And here you have access to Simulayos. Click here and you'll find what we just did as of yesterday and today, which is drawing the external and internal nodes. Quite happy with how far we've gone so far. Let's keep going from here. So one last thing I want to point out though, before continuing, is that I'm really liking doing these animations. Like, these look pretty good in my opinion. Sure, they're not there yet, but they look pretty good, like professional quality animations. And I'm very happy with that because it makes me feel like we're doing something right. Okay, so now let's talk about what we need to do. Let's do page, new page before. Okay, so first of all, how many characters are we reading in? It looks like we're reading in, oh, I don't know. I think I printed it out at some point. 82, is that how many characters we're reading in? I don't know, let's output something. Huffman visualization.cpp. Let's go into main. And let's see how many characters we have. So frame, animation, where are we here? Encoding, there we are. So we're going to decode final tree. Now we're going to do std, see how, let's say final tree root weight is, and then we want to do final tree dot root pointing to weight. And again, guys, if you have any questions, comments, concerns, let me know, and I will totally address them as soon as I see them in chat. Final tree root weight is, let's just pop this down to the next line. Yeah, that'll do. Okay, so let's go ahead and make it. Give it a second to do its thing. Okay, let's see what we have. Final tree is 127, okay? So let's think. We have the final tree weight as 127. So let's go here and draw some things. Okay. So the first thing is that if we have a weight of 1, then the position is going to be 1 over 127. So it's going to be equal to, basically 0.01. In fact, everything, 1, 2, 3, so on and so forth, are all going to be around the same order of magnitude, 0.02, 0.03. And we're multiplying this by the scale, right? But that doesn't really help very much. What we want to do is find a way such that we put them in a y position that is more spread out along the y-axis, right? Okay, so we could do this in a number of ways. So let's think about the best way to do it. A logarithmic scale, I guess, would make a little bit of sense here, where what we do is we say, here's 1, and here is 0, just like you'd expect. However, this guy right here is going to be 0.1. This guy right here is going to be, 0.01. This guy's going to be 0.1, so on and so forth. So like the tree leaves would then be spread out along here, and the root node would still be attaching down there. Okay. So now the question is, how do we actually do that? I'm really, really bad with this kind of stuff. So let's see. What we're going to say is we're going to plot. Let me think. So if it is of 0.01, we could do 10 raised to the y, I think. So let's see, if it's 10 raised to 0.01, we're going to get, or is it the opposite? Is it natural log? I don't remember. It might be the natural log, or the log base 10. Okay, I don't really remember. So let's see. 10 raised to 0.01 is going to give you, let's see, 10 raised to the 1 is going to give you 10. 10 raised to the 0.1 is going to give you, 1 second. I'm being really stupid here. Let me go over here and open up Julia. Okay, so Julia, and we're going to say 10 raised to the 0.1. This is going to give us 1.25. So do 10 raised to the 0.01. Okay, so obviously 10 raised to the 0 is going to give us 1. Okay, so let's do, what should we do? Let's do the log 10, I guess, of 0.01. It's going to give us negative 2. Let's see, of 0.1, negative 1, of 1, going to give us 0. Yeah, I know. Okay, so let's see. This means it's at negative 2. Let me think. How do we do this then? So if we have 2, 1, 0, this is basically what I want. Let me think. So we normalized it to our 127 value, right? So we have 0.01. Okay. We could do 1 over that. But that doesn't really help us out here. Doesn't help us out at all. What we could do, I guess. Alright, let's try this then. Okay, so I'm going to make this a full, or kind of like make this down a little bit. Let's open up our other terminal. There we are, and let's open up the animation real quick. So again, the problem is that all of these points are being drawn at the same location. All we have to do is spread them out in y. So let's do this. Log 10 C++. Okay, let's see, what do we need to do? It is just log 10 as long as we read in math.h. So let's go here, hey Witty Bands, and let's do it. So we have math.h already in, so let's modify the drawing of the y position and go from there. So what are we going to do? Let's go to draw external. And where are we? Vector position here. So temp position y. Let's see. So we have the max weight. Bomb dia. Why are you saying ew, Witty Bent? Hey, Watakanai, how are you? Why no McLaurin series? What is the McLaurin series again? Oh, 1 second. I actually don't know what the McLaurin series is again. I don't remember. Let me see. Is a series of Taylor expansions of the function about 0. Sure. Wait, how does this relate? Sorry about that. I'm not sure I follow. Okay, let me see. Yeah, I'm not sure I follow. Why, how does this relate? Okay. What am I doing? Okay, here we are. So, function approximation. Wait, why are we approximating a function? I don't think we're approximating any function here. Oh, don't use the inbuilt. Oh, I think I'm just going to use the inbuilt log10 function. Because... why? I think I'm just going to build it. I'm going to use the inbuilt one. Just for now. At least. Okay. Because I don't even know if it's going to produce the results that we want. Okay, so let's go here. Okay, so we're going to say... Let's see. So if we do log base 10 of 1, we obviously get 0, right? Okay, so let me think. What do we want? If we have log base 10 of, let's say, what do we want here? Log base 10 of 0.01, we're going to get, what do we want? Wait, let me do some tests real quick. So Julia, 1 second, this should be it. Log base 10 of 0.99, 0.99999. Okay, good. So let me think. Hey, Vientet, how are you? Okay, so let me think here. What we want to do, see, what's 0.9? 0.045. Let's do log base 10 of 0.1. This is going to give us -4. Okay, that's fine. But we want this to be... Let me think. Yeah, okay, so this should work then. I'm just trying to think of how to get it to fit into our scheme. So we have log base 10 of 0.001. That's going to be the maximum, right? So let's go through and let's do that. So we're going to say, here's going to be double, lowest, value is, or let's say lowest location is going to be equal to, let's do log 10 of what's going to be 1.0 divided by tree. We're continuing to work on the Huffman encoding scheme. Here you can see that we have everything drawn. We are appropriately drawing the tree. Now we're trying to space out these points so it's a little bit easier to see. So we've got a bit of stuff to get done here. Okay. Are these always coming off at 45? Oh, they're always coming. That's fantastic. Okay, good. Okay, what am I saying? It's going to be Huffman tree. Oh, no, it's just tree. Dot root pointing to weight. Okay, so then this should be our lowest location. Now all we have to do is go down here and we do the same thing and normalize it to this guy. So we're going to say log 10. Oh. Okay. Yeah, let's do it this way. Let's see what happens. So we're going to do log 10 of weight map key first, divided by tree dot root pointing to weight, and then we divide this by lowest location down here. So we're going to say lowest location. Okay, let's write this. Let's see how badly this breaks, because I'm really, really bad with math. Let's go ahead and make it. Weight map. doesn't exist because I think it's tree.weightmap. Let's make. Okay, give it a second to do its thing, and then we'll watch all of these new leaves being drawn in the incorrect places. Did you post your recent video on Reddit? I did. Oh, no, I did not, actually. Let's do frames. However, someone else did. Oh, well, that's interesting. Yeah, so someone else did for me, and I really did appreciate whoever did that. I'm not sure who it was. But that said, because it wasn't exactly related to a lot of people's stuff, it didn't quite get as many views as the eigenvector video did. So I think, and this is kind of what I was mentioning before, my next video I'm going to kind of go back to some basic math, because I did have a request from some people to do some basic math. So the math I want to do is determinants, because it's actually kind of cool, and it relates to the previous two videos of integration and also eigenvectors. So because it relates to both of them, it kind of completes a good story to tell, and so I think that's a good idea to go ahead and do that video there. And I like that idea. I like the idea that we do kind of random videos, and then another video that kind of connects a whole bunch of the random videos, you know? So that's kind of the idea. Can I get a link to this? Yeah, sure. So let's see, YouTube, this guy right here. So here's the latest video. Feel free to take a look if you like it. You know, obviously standard YouTube rules apply. If you like it, subscribe, that kind of thing. I don't really like at the end of my videos saying, hey, please subscribe. So I don't typically do that, but hey, that's how it goes. So let me think. If we are, one second, if we are at position, let's say 1/127, right? Ah, thanks, Driven by Him. I appreciate that. Okay, so let me think. If we have 1/127, right? We are at position. You don't have to subscribe if you don't like it. I totally get it. And if you like it, you don't have to subscribe either. It's no. At the end of everyone's video on YouTube, they always say, you know, please like and subscribe or whatever. And I don't like doing that at the end of my videos. So since then, or rather since like the start of time when I made videos, actually I deleted like 100 videos off my channel the other day. This is not Python. This is C++. Okay, let me see. What do we have here? Let me think about something real quick, guys. I'm really bad with this freaking... I'm really bad in general with life. So let's go ahead and keep working on this. Here's the thing. If we do, yep, Untello, it is indeed C++. Hey, Pretty On, how are you? So here's what we're going to do. If we do 0.001, and we do, oh, I think it's just 0.01. Sorry about that. 0.01 log 10. This is going to be 2, right? We're getting something like -4. So here's what we're going to say. We're going to say 1/127. And we know that this is going to be equal to 4. For some reason, the resolution on this looks way worse than it normally is, and I'm not sure why. Okay, so this is 4, or -4, right? So if we have another one that's 1/127, that means that our actual position is 1. Okay, now if we have something that's, let's say, 4/127, then what position is this guy? Then the position of this guy is going to be, what do we want? The position of this guy is going to be bigger, right? Oh, let's say we have a position of 1. Let's take a limiting case. So if this is log 10 of 1, then this is going to be 0, obviously. So let's see, 0 is going to be the top of the screen, 1 is going to be the bottom of the screen. So I think we just flipped everything on its head. Let me see what happens. Oh, actually, you know what? I'm sorry, Pretty On. Here's the idea. We're doing a Huffman encoding scheme, right? So Huffman encoding is basically a way in which we take a whole bunch of letters. Here's a whole bunch of letters, A, B, B, C, and we put it into an encoding scheme, right? And the encoding scheme could be whatever we want. We want it to be an optimal encoding scheme, as I wrote up here. And by optimal encoding scheme, I mean using the fewest bits. Then what we do is we say, okay, well, let's create a tree. And the tree is pretty simply made. We say, okay, well, if A has a percent of 70 to come in, B has a percent of 10, C has a percent of 10, D has a percent of 10, we go through and we work on it from there, right? Yeah, Boslakmon, you're right. Boslakmal, you're right. It was actually -2. And then we basically, you're totally right. I was incorrect when I said that. That's why I said 1 over 127. Anyway, 1 second. So what we do is we say, we add the two lows together again, two lows together again, and then we create this tree. And from the tree, we create an encoding scheme. We basically read it backwards. We say 1 for A, 0, 1 for B, 0, 0, 1 for... Yeah, I got it, Boss Like Mall. I appreciate it. 0, 0, 1 is C, and 0, 0, 0 is D. Okay, then we can basically encode anything with, let's say, a 2-pass Huffman encoding scheme, which is where we go through, find the frequencies, and then we do the encoding. So what we're doing right now is we're visualizing this. So here, let's go here and let me show you what we have so far. Right now we have this guy, which is basically all of the external nodes, and now we're drawing the internal nodes in the incorrect spots, which is where we should be drawing the or all of the parts coming together. So what I want to do is I want to fix the position. You're going to be the next big thing on YouTube? I don't think so. The thing about YouTube is, I speak so much about YouTube on this channel, but I think it's okay if you guys are okay with that. Thanks, Woody Bants. I really appreciate that. But yeah, so the thing is, when it comes to YouTube, you've got to be very, how do I do this? You've got to be very good because there's so many people on YouTube. And the thing is, I've got a friend. He's got like 3 million subscribers right now. I met him in kindergarten. He was my best friend for the longest time, but high school came around and he was too cool for me. And so we didn't hang out anymore. And that's fine. I totally get that. I was a huge nerd in high school. Rather, they saw me as a huge nerd. I was actually on swim team and like super athletic, but that's a story for another day. The idea was, but he's got like millions of subscribers. And for me, I'm thinking to myself, crap, if I could have that many subscribers, think about how much good we could do. I mean, we could have, I just, in my mind, I was thinking, think of a community with so many people in it. Man, I was just so excited about that. So that's kind of why I started YouTube to begin with, but it's really hard to do, to be like a, you know, #1 YouTube guy. So what I'm doing instead is I'm opening everything up, and that's what I'm doing here on Twitch. I'm making sure that all of the simulations I do are there and ready for anyone who wants to learn from. And that said, I'm learning too. So I think it's good. And that's kind of the whole project. You know, I want to do simulations. I want to show people what's really cool about science and programming and physics and all this kind of stuff. But I also want them to have the opportunity to see me while I do it. So they know that, you know, so they know that I, how do I put it? So they know that I struggled with the material too, you know, that kind of thing. So, but I really do appreciate it, Witty Bants. Really means a lot. Okay, so now we have to draw the internal nodes. The internal nodes are going to be drawn in about the same in about the same way as the other one was. So let's do the same exact thing we have here, double lowest location, just to make sure that they have the same location. Hey, Edge226, I'm fantastic. How are you? Let's go here and find X position is already done. So let's go here and do double lowest location. Here, node 1, node 2, node parent. Seems all good to me. Now here's the thing. We need to change the Y positions here, and we did it 3 times. So we're going to say node parent weight over final tree root weight. This is not what we need. We need what we did up here, which was, where is it? Oh, here it is. Tree weight map key first. So this is going to be the weight, log 10 of the weight divided by this guy. So we need this. Let me pop back down here. Let's see if I can get them both in the same guy. You should really always shout your videos out on Reddit, especially if they receive good comments. Yeah, the thing is, the last video did incredibly well on Reddit. But again, this one, this past video was about Monte Carlo simulation. Where was I supposed to put it to? I put it to our math on the last one because it was eigenvectors. I could put it to our programming, but our programming wants a different type of thing, you know? And so our physics might like it, but this wasn't really physics. It was somewhere in between math and computer science, so it's not going to do very well. But the next video should do quite well, I think, on our math. So that's kind of the idea. The thing is, I'm so far away from anything that's worthwhile on YouTube. So, I need to be, like, I'm at 780 or something subscribers right now. Oh, cool. Yeah, let me know, HG26. So, anyway, let me see. What do we do here? Double lowest location. But the thing is, it was posted by someone else. And that's okay. I actually really like the fact that the people who watch my videos like it enough that they want to post it on places. I think that's really cool. Like, actually, that's super cool. You can actually post a direct link, Edge226, into the chat if you want, and I'll take a look at that. We don't have very many trolls on this channel because it's not a super high popular channel. So because of that, you're fine to post links. I let people post links without any problems. Okay, let's get this done because I've been sitting here talking about YouTube for the past 20 minutes and we're here to do coding, right? So let's do this. Parent y. Node parent weight divided by final tree dot weight. We need to change this a little bit, so it's no longer going to be divided by final tree dot weight. It's now going to be divided by, what am I doing here? What am I doing here? Oh, lowest location. And then we do node parent dot weight, but instead this is going to be log 10. Why are you a troll? Let's see. Weight. And now what we do? Weight. And we want to divide the weight by... What am I dividing the weight by? Oh, obviously the root weight. So we're going to do final tree dot root pointing to weight and parentheses, and then we're going to divide this down here by lowest location. Let's see. I've always wanted to be a physicist, but my math side of my brain is left me down, and now I'm going with English, literature, and language. Sad but good too. See a physicist streaming programming on Twitch. It gives me a chill at night. Trolling is fun. That's fine, Untella1. What level of education would one learn about eigenvectors in the U.S.? In the U.S., let me hit Vientets first. So when I entered college, I actually wanted to be an author, and then something happened and I became a physicist. So I totally understand trying to go one place and ending up another place. But the thing is, if you enjoy what you're doing, that's all that really matters. The other thing I want to point out is that physics is hard. It's not intuitive. It doesn't make sense. Programming is hard. It's not intuitive. It doesn't make sense. But you can approach it in a way that does make sense, you know? So if you take a step back, I feel like it's just a matter of figuring things out intuitively. Like for me, my math is horrible. I'm very bad with math, but I'm okay with programming. And so I approach physics in a programming way, and it kind of helps me out. And so maybe there's a way for you to approach physics in a way that makes sense for you. Witty Vance, what level of education does one learn about eigenvectors in the US? I think we learn about eigenvectors actually year 2 of high school, when we do, or year 3 maybe, when we do algebra 2 with matrices and stuff like that. If not, we definitely learn about it in college when there is when we do linear algebra there. So I think that's okay. Even for programming, there are so many ways to do the same thing. Yeah, I mean, here's the thing. Programming is one of those things that everyone does differently. You know, it's like writing a book. You know, everyone's going to have their different style. They're going to have their different way that they do it. I usually like writing things out explicitly. I like Fortran-y style because it makes sense to me, you know, because I learned basically scientific programming from Fortran. So that's kind of what makes sense to me. But it's ugly code. So I've been trying to make my code look prettier. Yeah, so it's around the same time then for the people in the US, definitely. But again, if you did not learn it very well in high school, you will learn it again in college. The problem was both of my linear algebra classes were awful. In high school, we did not have, well, okay, let me rephrase that. I did not learn anything in those linear algebra classes just because of the way they were taught was not, I just didn't learn very much from them. So that's what happened. Okay, so let's keep working on this. So we have log 10 here. We do the same thing down here. So it's log 10 of node 1 weight divided by final tree root weight. Okay, well, that turned out. And now what we do is we divide by lowest location. Okay, and now we do the same thing down here, and it's basically log 10. And we divide this by lowest location. Oh, sorry about that. Okay, and end of parentheses. Let's write this and let's see what happens if we make it. All right, error. 389. Lowest location, final tree. Make. Let's see. I'd be interested to read the curriculum and what it's about in the US Math SAT or Algebra 2, not tested on SAT. Algebra 2 should be tested on the SAT. Where I was from, I took the ACT. I don't remember what it stands for, but it's basically the same thing. Let's see. So we have all the positions being drawn, and oh, good. Okay, that looks like we're drawing trees, right? Good. 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 Okay. Okay, good. So, let me see. Was Algebra 2 not tested on the SAT? It is totally tested on the SAT. Now, the thing is, how do I put this? There's a difference, in my opinion, between being able to do things analytically and being able to understand them intuitively. And that's the thing. In the US, at least, we're taught how to do things, but we're not taught what they mean. And so it's a matter of, how do I put this? It's a matter of learning that, and that's kind of hard to do in my opinion. Okay, so let's go ahead and draw this out a little slower. So obviously all the dots are being drawn. What I want to do now is I want to draw each of these lines just a little bit slower. And since we're using a draw line command, it should be okay. So let's do draw internal. And where are we? We are animate line. So we give it time divided by 100. Let's give it time divided by, let's say 50. Not 560, 50. Okay, let's go over here and let's make it. And let's see what happens. Oh, oops. Screwed that one up. My bad. Let's fix this one up. What's on Algebra 3? Algebra 3, let me think. That's way back in high school for me, so I have to think back a little bit. I don't know if I took Algebra 3. I think I just moved right to Calculus. By the end of high school, I had already taken Cal 1. In fact, I skipped out of Cal 1 in college because I had already finished it. So I took a bit of a different curriculum than what most people do. I don't know what's actually in Algebra 3. I have no idea. I wish I did, but I don't. Oh, animation is done. Animation.gif. Okay, let's see what we got here. Should draw lines. Yeah, okay, this looks a little bit better. See how the lines are being drawn a little bit slower? Okay, so now what I want to do is make it even slower. So I'm going to assume we have 20 lines to draw. This is why you use constants. What do you mean this is why we use constants? I apologize, I'm not quite following. Okay, so let's go through. Oh, I see, because of that. Yeah, you're right. In fact, let's just go ahead and do that up here. So let's say int, oh well, yeah, int, fine, num lines, and we're going to set it equal to 25. Let me think, does that make sense? Let's say 30. Why not? It's just a rough order of magnitude here. So now we're going to go here. Hey, clone style, what's up? And we're going to say double of num lines. Okay, let's go down here, do double of num lines. Of num lines. Ah, man. And we're going to have to pop this down somewhere, or we just do this. Because guess what? I'm bad at programming. So then we're going to do this and do double of num lines. Okay, let's go here. Let's make it one more time. And let's see what happens. Okay, so next thing we need to do after this is done, I like how this tree looks. Granted, I kind of like, it's fine. Okay, so we're gonna do mirage animation.gif. Okay. And there we have it. The tree is being drawn, all the points are being drawn, all of the little guys are being drawn in them. That's good. Okay, so now the last thing we need to do, why do you cast to double? Gut feeling says double divided by int equals double. You might be right. What's the worst that could happen? Let's do it. I mean, I think you're right. Why not? Let's test this real quick. So I'm gonna open up a file. Let's do double check.cpp. Okay, here's what we're gonna do. We're gonna do include iostream int main and this std cout. What do we want? Let's do 7.0 divided by, let's say, 8. Okay, then we're gonna do, okay, 1 second, I'm just that's fine. Hey Slayer Darth. Okay, so next we're gonna say 7 divided by 8.0, and then obviously the next one's 7 divided by 8. 7 divided by 8. I trust you guys. I'm already committed. Let's do g++, double check, .cpp, a.out, 8.75, 8.750. Okay, yep, you guys are right. No need to cast a double. I've just been bitten by this before, so I'm always super cautious when it comes to doing this kind of stuff. Because even the other day on this stream, I accidentally did something that was obvious, but I screwed it up. You know, I just ended up, like, because I accidentally didn't cast a double to an integer, and that screwed everything up. Okay, so let's do g++ double check.cpp. No, I want to do make one last time, and then we're going to keep the image up because there's one last thing I need to do, and I haven't quite decided how I want to do it yet. Okay, so let's do let's mirage animation.gif. There's a couple more things I have to do. Why don't you use constant expression int? Because I don't know what constant expression int does exactly. I'll look it up. Hey Lucky Box, thanks for coming in. Okay, so this looks pretty good, but I have a couple of qualms with it. I get what you mean about high school understanding. Is he using C++11? I am using C++11. I've been using C++11 for a while on this channel. Okay. I'm not trying to be condescending there. I apologize. That sounded really condescending. That wasn't what I meant. It's that a while ago, I was kind of averse to using a lot of the new C++11 features. I've been getting better and better at using them since we've gone along. Okay, fair enough. Thanks, Clone Style. Let's evaluate at compile time. Is the channel Simuleos entertaining? Yes. Is there a specific reason you chose to answer above? Oh, yeah, fair enough. Constant expression is some C++17 magic, I think. Oh, wow. And it only works with primitives. Ah, I see. Okay, so here's the problem, guys. These white lines are being drawn over the green balls, if you know what I mean. I meant it literally, like literal types here. I meant it also literally. And I don't know if I like that. However, if we don't draw them over the green dots, then we run into some other issues. So I'm trying to think of the best way to visualize this. Hey, the Bandit Dave, what's up? And I like the way it's currently being visualized. I actually really like this. So I'm going to leave it like this for now. The only thing I want to fix is the starting location of each of these lines. And I'm trying to think of the best starting location for the lines because it's not exactly obvious where we need to start them. So here's my current problem. Let's go here, page, new page before. And I apologize, there was a big white screen out of nowhere. I realize it's probably late at night for some of you guys. So big white screens probably hurt people's eyes. My apologies. Okay, So here's the thing. We have the ball. Here's the ball. We have a position where it needs to go to. There's a position it needs to go to, and we're drawing from here to there. Now, why is the resolution so low? Anyway, it's fine. Doesn't matter. Who cares? We have the radius of the ball as r. We have the angle. Let's say it's trying to go to this position up here instead. We have the angle as theta, which we can find. So all we need to do is find the angle and then go from there, I think. Yeah, we'll see. Reading documentation for a project. Ah, cool. What kind of project are you working on? Okay. So this is what we're going to do. We're going to draw it without putting the lines in the center of the dots. And guys, for the record, just because I did mention this earlier, I'm going to take a break from the Huffman encoding stuff tomorrow because I have not yet finished the dynamic Huffman encoding stuff. And because of that, I'm not at a position where I feel particularly comfortable working on that yet. So I'd like to get a little bit further. Now, one thing I wanted to do was kind of make this look a little prettier by changing the way the lines are drawn. Instead of being drawn straight lines, to make them curved lines, to make it look like a real tree, but that's so much effort, and I feel like I don't want to put that much effort into this. Anyway, we'll see what happens. Because this actually gives you the exact information you need. No problems there. So, drawing internal. What do we have here? We're going to say, indeed I am. I'm playing with a website called codinggame.com. Yeah. Okay. So, node 1x, node 1y. Here's what we need to do. Animate line. Okay. What we're going to say is, what do I want to do here? Node parent x or 2. Okay, so we're always drawing to a parent. So what we're going to do is this. We're going to say if there exists in node 1. 1 second. Node 1 dot key, which means there is a character in there. We change the way we're animating this line. Okay, and we do the same thing down here. So we're going to say if node 2 dot wait. Oh, come on. Key. Why can I not type? We're going to go here and there. And now we go down here. Okay, now what we need to do. Oh, and James, that awkward moment when you're wondering why your C++ script didn't compile properly, and then you realize that you failed to type GCC in the terminal. Yep, I've definitely done this. Can't you just subtract the radius from the circle for the line location? Yep, that's exactly what I'm going to be doing. However, we have to check the angle at which we're going to. And the reason we need to check that is because we need to make sure it pops out at the right angle. So that was kind of the thing. It's not directly obvious, so I drew a quick diagram, but it is decently obvious. You're right. Okay, so now we're going to do else. 1 second. Else. And one thing to note about my programming style. Else. I've got a lot of boilerplate code, and I'm letting you know that because I like having the boilerplate code there. Like, for example, this if statement is not ambiguous. I know what it's doing in a way, you know? And I like code that's not ambiguous, you know? So sometimes I will make very long code that looks very ugly just because it's, in my opinion, more readable, but it might not be more readable for other people. And I totally get that. So we now need to create a new X location, X and Y location. Let me see. Okay, so what I want to do, we're going to say ori.x is going to be, first we have to find the angle. So let's go and define up here, double angle. Double angle. Okay, and we're going to say angle here is going to be equal to, let's see, we have the new position, we have the old position, so it should just be, let me think, sine is going to be opposite over adjacent. So I guess it's going to be a sine, right? Or we could do a cosine. Doesn't matter. Either one will do. Or arctangent. Why not? Arctangent works. Let's do arctangent because I like arctangent. Oh, but we have the radius. Yeah, let's do arctangent. That one's good. Okay, so we're gonna do atan of, let's see, so it's gonna be opposite over adjacent. Can't you simply draw the line? Draw node 1, draw node 2 instead of trigonometry? Yeah, we can draw the line. In fact, that's what we're currently doing over here. The problem is that atan 2, we will do atan 2 then. Thanks, man. Okay, we can draw the line. The problem is, at this point in time, we are putting a, how do I put it? A line right through the green dot. Now we could do this in we could fix this problem with a number of different ways. Novelist. Wait, what? 1 second. Again, the problem is the actual location of the dot is different than the radius of the dot itself, right? So here's the location, here's the radius of the dot. Let me see, am I maybe missing something? Draw a line, draw node 1, draw node 2. Oh, I see. So yeah, we could do that first, but the thing is I want the dots to appear, right? And then I want the lines to appear. I'm doing it this way first, although you are totally right. There is another way to do it. And the other way to do it is to redraw the dots at every single point. And that's perfectly fine. I could do it that way. I like having the dots appear first because it makes intuitive sense to me. Each of these dots is a character, right? That we're going to be encoding. And so it's important, I think, to have these drawn first. And then we draw everything else from there. I'm trying a couple of different visualization methods though. So at this point, you're right. This is kind of up to interpretation. So after I get this done, I'm going to submit it to GitHub one more time today. And then you guys feel free to do whatever you want with it. Totally up to you guys. That's fine. Let's go ahead and get this done. So it's going to be opposite over adjacent. So opposite is going to be the height or the y-axis. So it will be, sorry, ori 2.y subtracting ori.y, and we're going to put this in parentheses. That's why I'm doing it in Python. Let me see, Novelist. Yeah, I thought so too, Dr. Kegel. Novelist is pretty fun, but some of the stuff is not like this. We're doing it in Bash. When you get the solution in a language like Bash, yours seems like good. We could do that. Here, let me think. It's because of how we're drawing it, right? I mean, you're right. We could just redraw the circle. And that's fine. We can totally just redraw the circle. I think it's better just to start. I think this will work just fine. It's in my opinion intuitively simple. So we're gonna go to ori2.x minus ori.x. Okay, now we have the angle. Now all we have to say is the ori.x is going to be equal to ori.x. And let me think. So if we have a position that's on this side or that side, right? So let's say we're going to the left, right? In this case, let's see, we have an angle. I think we should, with atan 2, you don't have to divide. Oh, I don't know. Is that what it expects? Okay. I was expecting it to want something else, like what arctangent wants. But thanks for the information. Does your drawing function take 2 points? Yes, the drawing function does take 2 points. And we're reading it in with the 2 points. Okay. Good. So let's go here. Ori x is going to be plus. What do we want? We want radius. 1 second. I think we are reading in a radius. Yes, we are. Radius times it's x, so we want cosine of angle. Then we want down here, same thing, ori.y is going to be equal to ori.y plus, and I realized I could do plus equals, my apologies. Oh, it's y.x. Good, okay, we have that right. Oh, that was meant to be a plus sign, not an underscore. Radius times sine of angle. What do we have here? Wikipedia, define and computation. Thanks, Intello. I appreciate it. Okay. So now we do the same thing down here. Let's see, here we are. And then of course we animate the line. So I forgot to do that up here, my apologies. Oh, actually, you know what? It's gonna be the same line regardless. So let's go ahead and just remove this, 1, 2, 3, 4. There we go. And then down here, we can remove this, 1, 2, 3, 4, 1, 2, 3, 4. Up here, let's go ahead and copy these guys because they're gonna be just about the same. Paste that down, d. Angle is gonna be arctan 2 of Ori 2 minus Ori, what do I call it? Oh, it's still Ori. Wow. I just reused variables like crazy. That's okay. Okay, let's make it. Here we are, make. Oh, it's gonna break. That's okay though. That's perfectly okay. Give it a second and let's do Mirage animation.gif. Alright, let's see what we have. Oh, actually, that doesn't look too bad. They're all starting where I want them to start. They are drawing over the internal nodes or the other points, which I think is okay for now. I think that's fine. So here's what I'm going to do. I'm going to go ahead and commit this version to GitHub, and let me do wquit, write and quit. Sorry about that. Then we're going to do git commit Huffman visualization.cpp, and we're going to say message. Oh, let's do it this way. Actually, real quick, let me run a git status. Make sure I didn't miss any. Oop. Didn't miss anything. Huffman.cpp, Huffman. Oh, shoot. Oh, shoot. Oh, shoot. Where are some of the lines offset from the nodes? I'll take a look in just a second. Actually, let's run it here. You guys can take a look when you draw it, but I think... Let me think. It looks good to me. This looks like exactly what I wanted. All right, let me do a git, 1 second. Git commit, and I want Huffman.cpp, Huffman.h, and then Huffman visualization.cpp. Now we're going to say added, let's see, new Y locations for external nodes. Oops, sorry about that. Nodes no longer draw over initial nodes. And one last thing is going to be added, necessary compile files. Okay, let's write and quit, git push, and this should be it. Okay. So now you guys should have access to everything. I apologize, last time I committed it, I failed to commit Huffman.h and Huffman.cpp, which made it so it probably would not have compiled with the make command. But now it should be available. All you have to do is cd into the appropriate directory, which I will pwd, simuleos Huffman, run the make command, and it should make this exactly, assuming you have Cairo installed. So again, you can mess with this on your own machine if you want. Okay, so now the next thing we want to do. I want to put a letter in each of these bubbles. So let's do Huffman visualization.cpp, and let's put a letter in each of the bubbles. Okay, so where are we? We're in grow circle. Let's see, draw external is probably where I need to go. Draw external. Okay, here we are. Now, text in Cairo is kind of weird. I haven't quite gotten used to it yet, but I need to get used to it. So I think it's probably good to work on this here. Let's do init. Wait, what am I doing? This isn't what I want. Here we are, draw external. So we do draw grow circle, right? And then in the grow circle command, I believe we set the color, I think. So let me go up to the grow circle command and let's see, grow circle. Really quickly, I'm gonna get a sip of water. Sorry about that, guys. And I feel like we should do one more thing. But we'll talk about that in a bit. Alright, it's Juicy6. Have a fantastic evening. I totally get it. It's probably late your time. So, have a good evening. Okay, so what am I going to do? I'm going to... Put a letter in each of these circles. I left for a minute? You left frame for a second? I left frame for a second. Oh, did my stream go down? Sorry about that. Anyway, have a fantastic... Oh, you're talking about getting a sip of water. My apologies. Oh, come on. 320? So you're in the US then. Good. I like having viewers from all over the world. It's really cool. You know, I'm in Japan myself, so it's really neat to see people from Europe and the US and stuff like that. It's just neat. Okay. So what are we going to do? We have all the circles being drawn. And it looks like we do set the source RGB. Wait, you're not in the US? Oh, are you in Canada or South America then? One of the two. Central America, maybe? You're somewhere on the American continents, plural. Untella 1, you're probably somewhere in Europe then. Yeah, again, it's just neat. I mean, Canada. Ah, good. Sorry about that. I just guessed. November, I don't know, 11:20 p.m. Somewhere UK-ish. I don't know. Sorry about that. I'm not that good with time zones. I wish I were better. Zero. I don't know where everyone is. I apologize. But it is neat to see people from so many different places. Okay, where are we? We already did animate line. What do I want to do? Lucky box. Draw external. Yes, this is what I want. So now we want to put a letter in each of these guys, right? Problem is, text is, again, kind of difficult with Cairo, so I'm going to have to drop this down for a bit. And let me go into LS. Let me go into the following file. I believe it is subroutine webcomic. Let me see, what do I have here? Subroutine.cpp. Okay. So we should have something to do with text. Write text. Okay, so this is kind of the thing. So we have write text here. Write text here. Okay. So this is all just to write write text. 1 hour off. Dang, I was close. Okay. Edge 226. I totally understand. As someone who goes to bed at like 8:30 in order to get up at 4:30 for streaming. Actually, I don't go to bed at 8:30. I normally go to bed at like 9:30 or 10. But as someone who, in order to get 8 hours of sleep, would need to go to bed at 8:30 in order to get up at 4:30 for stream, it's one of those situations I totally understand having weird sleep schedules. Okay. So what we need is this. Oh, what am I doing? I don't know. What did I just do? I don't know. Here we are. Okay. So here's what we need. We need to find how big the text is that we're writing down. FHP. Oh, also from Germany. Good. Okay. So we need to set the font size, we need to set the source, so on and so forth. What I found out is that the font size is pretty darn accurate here. So if we put a font size of 10, it will exactly fill a space of 10 pixels by 10 pixels. And that's good. That's exactly what we want. I'm not going to worry about changing the font text here. So we just need to worry about the size and stuff like that. Every time we grow a circle, we have external nodes.size, we have Huffman tree, and because we have Huffman tree, we should be able to figure out what the, let me think, external nodes, what the actual letter is. So let me go up here and do std vector of characters. Std vector of characters. This is gonna be a little bit weird, but that's okay. Then what do we want? We want internal, let's do characters. Why not? This is good. Okay, so now we're gonna go here, temp position X, external nodes pushback temp position X. Now what do we want? We want temp position Y, weight map. Wait, let me think here. We have a weight map for auto key and tree. Let me see. Why are you in Japan? You seem very American to me. I am incredibly American, but I'm in Japan because I'm attending graduate school at the Okinawa Institute of Science and Technology. And because I haven't at all advertised OIST yet today, I'm just letting you know that's why I'm here. It's a fantastic university. I really like it a good bit. And it's kind of new, so I'm hoping it's super successful. To be honest, one of the reasons I'm streaming is because I don't know, I have the opportunity to do so, and I feel like maybe in some ways I could help Oist out a little bit in some ways. I don't know. It's not like I have a moral obligation to help out my graduate institution. It's just I really like this place, you know, and I'd like it if smart people applied. So anyway, that's completely beside the point. Okay. If it were teaching, yeah, I think it'd be fun to do teaching. But anyway, that's beside the point. My Japanese is awful. I need to learn more Japanese before I do any type of teaching here. Okay, external nodes push back. That's not what I want. I want characters. Dot push back. And let me see, what are we? We're going through each of the tree in the tree bitmap. So what we need to do is push back. What do I want to push back? I want to push back, what is it? Tree. Dot. Not weight map. Oh, no, I just want to push back the key. Key dot first. There we go. That's all I need to do. Okay. No, that's not what I meant, Lucky Box. It's just, obviously, a university prides itself in its students, right? And that's kind of the idea, right? So, have a fantastic evening, Basakma. Thanks for coming in. I appreciate it. See you around next time. Okay, so now we have bitmap size. What do we do? Okay, so we have this. Now we have to place the text in here. So let's go here and say placing text in circle. Okay, so here's where things get complicated. First thing we need to do is find how big everything needs to be. So let's go up and go here. No, it's okay. I figured. Let's go here and let's set things. So when I did init, did I set text size there? Let me go up to init. Let me see. Init. Frame init. Here we are. So I think I set text size here. Let me see. Did I? Text. I did not. Okay, so let me go back up to where I was before. Let me see. I think it should be init. Here we are. Let me set text size in here. So we're going to do Cairo set. What do I want? Oh, I do set font size. Let's set this as 10 for now. We might change it a little bit later. I think that's all we need for that. Now we do Cairo set source RGB. Good. So let's go down to text. Okay. So here we're going to do Cairo set source. Source RGB. And we want it to be double external nodes of I. Let me think here. We need to set... Yeah, okay, so we need to set frame context of current frame dot, sorry, anim dot current frame. And then, yep, that's right. And then we want to set RGB to ones, I think. I always get it mixed up as ones or zeros, but that's fine. So now we have to find the extents of the text. So we're going to say Cairo. And this is basically telling us how big each letter is. And this is super useful because if we get the width of the character, we can then move it into the appropriate position, right? So we need the width of the character. So we're going to do Cairo text extents, sorry about that, T, and it's going to be text box. Okay. Then we're going to go down here and say Cairo. What do we want? Text. Extends. Jeez, I'm really bad at this. Then we want, what do I want? I want frame context. Oh, sorry about bumping the desk. Frame context of anim.currentFrame. Okay, now what do I want? I want text.cstring. So in this case, I'm going to want external nodes.size. So I'm going to want characters of I and sorry. Then I want text box right here. And this is putting text box into or giving text box the appropriate size. Now we move to the appropriate location. So we're going to do Cairo move to, and the location is going to be frame context of anim.current frame. Okay, and now we want to move to basically the location that we're at. Bless you. You can say bless you. I'm from the south. I get it. Okay. What do we want then? We want Cairo move to the appropriate location. What is the appropriate location? It's going to be, we have the location, external nodes. Let me see. Okay, good. So what do we want? We want to move it to external nodes of I dot x, and then we want to subtract out textbox.width divided by 2. Fair enough. Okay. There we are. Textbox.width divided by 2. I'm just going to copy this here. We're going to have to do the same for text y, I believe, and let's see what happens. So we're going to do external nodes of I dot y minus textbox.height. I did call it textbox, didn't I? Yeah, I did. Height divided by 2.0. Okay. And that should be the y location that we move to. Now we basically show text. So we do Cairo. Where is it? Show text. And we read in frame context. Where's the X? I got the C, then I got the Z, then I got the X somewhere in there. Context of, what am I doing? Anim.current frame. And then we do frame context, anim.current frame, text.cstring. So this should just be characters of I. Is that it? Then I think we just stroke it and we're done. So Cairo stroke. What do we want here? Frame. Oh, you know what I forgot to do this whole time? I need an anim before each of these guys. So anim dot. And of course with VI, it's super easy. We just press the period button to insert each of these every time. Okay, now we go down here and we do anim.frame context of anim.current frame. Are we still in init? No, we're in, gosh darn it. And we're done. Yeah, just stroking it. That's kind of the nice thing about Cairo. We're just able to stroke it. And that's all we need to do. It's pretty neat. Okay, so text box was not declared in the scope. That didn't happen. Characters. Okay, let's make it. This should work. No, shoot. Why is it not working this time? Huffman visualization. Oh, failed. Invalid conversion from. What do we want? Screw it. I'm putting a .c strings at the end here. Cairo text extents. What? Lucky box. I don't even understand. Okay, let's go here. What do we want? Here, I also want .c string. And this, I hope, works. Let's make it. Let's clear a couple times, making sure we're reading the error messages. Okay, what do we have? .c string. Let's see. Request for c string in characters std vector. What? Character, which is of non-class type. Okay, let me do something real quick. Let's go here. Let's remove the c strings and let me see what it's giving me a problem with. Where is the last c string? Ah, there it is. Okay. Let's go here. Let's clear a couple times. Clear. And now let's run make. Okay, it says in function void draw external. Invalid conversion from, let's see, aka character to constant character star. Okay. So it's going to give me this problem twice over. And the reason is because it doesn't like what I've given it. So let me see. How do I convert a character to... Why don't I just... let me try something. Let me just do this. Now let me cheat a little bit. Let me just try. Warning, cast pointer integer to different size. Cast a pointer from integer of different size. You know, instead of doing clear, you could just do clear or clear up enter. Yeah, I don't know, I got in the habit. One of my previous postdocs that I worked with, or one of the postdocs I worked with previously, always just wrote clear in the terminal all the time. And I told myself I would never do that. You know, I don't need to type in clear. I can just press Control L, which does the same thing, and just clear it a couple times there. And then somehow I just ended up doing it. I ended up just typing in clear all the time. And now I just can't not do it. And it drives me nuts because on, for example, MATLAB, every now and then, char x, character x equals 0, void p equals void star x. I'm not sure I fully get that one. Let me think. Sorry, I was falling down. Let me think. What do I need to do? I need to, I don't know what I need to do. Let's just go here, converting character to character star in C++, Google foo. Okay, SE string to char star. Usually people just use, yeah, .c string. Casting a byte to a pointer. So my question is, why doesn't .c string work? What if I do this? Let me go up here. Well, let me just do up here to the very top. Char, temp, char. Okay, let me see what happens if I just go here and I say temp char. Constant char star C string. Let me see. Char C equals X constant char star C string. Oh, let me try something. Let me go here. Let me say temp char. It's going to be equal to characters of I. We're going to go down here and say temp char.c string. Roses are red, violets are blue. Press start and join and be, aw, that's cute, Husky. But I'm still not coding in HTML. Okay, let's go ahead and make temp char. Make temp char to C string in temp char, error invalid conversion. Dang. Thanks, Edge226. Make. Holy cow, come on, cannot convert. Okay. This should be a super easy thing. I'm just for some reason failing. So let me see. You say char C is equal to X, constant char star C string. Okay, so what we want is the following then. Let's do characters of I. I'm trying to follow too much boilerplate code, too hard to read to figure out what is going on. Sorry about that, Untello1. Okay. Let me see. So if we put a asterisk here, let me think. So you're saying constant char star C string. I don't think this is, I'm really bad with pointers, guys. Let me see. Argument of unary. So we have, let's go up here to temp char. Let's say, what do we want it to be? We want it to be constant char star. Okay, now let's go down here and let's say temp char is going to be equal to this. Then we go down here and we say, 1 second, temp char. Let's go here and make. Invalid, let me see. Argument. Let's go here and make. Let's see. Invalid conversion from. You know what? Screw it. We're changing this. I'm just having too much trouble with characters. I hate characters. Let's go here. I'm doing this. One second. Go up here. Let's make. Dang it! Key that first. Error, no SD character. How do we change a character to a string? Let me think. Can we do it this way? What if we just keep it as a string? Instead of SD vector, it is just an SD string of characters. Okay, then we go down here. And we say characters of I. Where are we? Where is keyed up first? Characters, push back. Instead of push back, we're just going to say characters plus equals. Dagnabbit. Why am I having so much trouble with this? This was supposed to be, is characters I char and or something? It should have just been a vector of characters, right? Then the question is, how do I turn character into a C string? So let's do character, char, C string, C++. You need, but it won't be null terminated. Let me see. Delete C string. Character star C string is equal to new char string length. String copy, is that what I need? Let's look up that one. Okay, no. Sorry about this, guys. Let's do string.c string. That should be okay. But how do I get... Why is this so complicated? C string function. No, I want... How do I... Character to constant character star. Let's see, how do I... Now I don't want the difference. I want converting from a char star to constant. Nope. No. This is not what I need. I need to... I have characters. I need them to be character stars. Let me see. What if we do the following? Let's do std vector of, I don't know, constant char star. I don't know. This is annoying. Let's go here and let's change this to the following. If you couldn't tell, I never deal with strings. Char temp is equal to 0, 0. Temp 0 is equal to characters I. Char temp. Let me see. Make. Okay, let me see. Characters plus equals. Obviously, that's not going to work. Misspelled push. Let's go here to make. I'm trying to figure this one out. Untello 1. Character temp. So we create a temporary array of 0, 0. Then we say temp of 0 is going to be equal to characters of I. Is that going to work? I don't know. I feel like pushback keyed up first. What if we do... Okay, well, I don't remember what I stored these as. Couldn't you do char temp? I'm not sure what that means. I have no idea. Char temp. So what you're saying... I'm not sure what this means. Can't remember if the expression must be evaluated at compile time. Let me see. How about C string? Let's see. Character C++. Let me see how to convert SD string to constant character. Setting a character array. Constant char element myvector1.cstring. Myvector1.cstring. What is a myvector? Is a string with 3 letters in it. Dang. How do we convert char to string? C++. Okay, what do we have? Character array. Let's see. Character array, this is a test. String. Let's do this then. One second. So need to be make what? Let me see something. str C++. Sorry about being so scattered. Let me see. Oh, it's SE string theme. Wait, what? 1 second. I don't want to have to use string stream for this. That's kind of a pain. I don't know what you guys are doing over here in chat. Char temp2 is characters I0. And I don't know, that just doesn't... I'll try it. So let's go here. Let's go here to character. Temp character. Let me see. Again, I'm just not sure what this is doing. Like, I just don't know. Why would we? This seems like so convoluted. I feel like, okay, whatever. So we'll say this is, why can't we make it of size 1? I'll see what happens if we make it of size 1. Now we go down here and we say temp. Yeah, but why do we have to, why 2? I don't. I really hate strings with like a burning fiery passion. What? Why can't, it's just so convoluted. It just doesn't make any sense. Honestly, I haven't actually. Sorry to be a pain, but what are we trying to do at the moment? Push characters with vector strings. Basically that. Yeah, 1 second. Okay, so we'll say... Anyway, we're going to set this equal to... C-string needs an end of string marker? Okay. Sure, whatever. Okay, so we're going to do this. We'll say... characters... of I. Okay. Appreciate that. Sorry about that, guys. Again, this is probably super frustrating to watch. My apologies. Let me go here, temp character, here. Ah, dang it. Let's go ahead and clear. Let's see, make. What do we have? Error std. Yes, that's because I screwed up there. Okay. Let's do this. There. Let's go here and make. What do we have? We're in C++ just 11 vector variable name pushback character variable name. Best case scenario is access violation. Let me see. And then there's reading whatever garbage happens to be in the memory there. Yes. Okay, so let's go ahead and clear. Let's try running it one more time. Okay, so it says error, no matching function call, pushback, character, what? Key first. Oh, this needs to be character real quick. Okay, let's make it again. Let's see, what do we have here? Error, conversion from type character, that's because it should be 0. And this should be 0. make invalid conversion from char to constant char star. Best case scenario is access violation. The curly braces will get you the constructor you're looking for. Let me see something. Buffer 1 0. Okay, so what we want then, you call it buffer. Okay, so let's go up here and set this equals 0 0. Let me see what you're saying. Okay, let's try that one in a bit. Don't pass. Yeah. So what you're saying is I need to pass this. 1 second. Oh, okay, without 0. Okay, fair enough. Okay, let's go ahead and write this. Let's go over here and make. Okay, cannot convert char star 2 to constant char star. Let me see. I guess we go up here. And do we change it to constant? Let me see. Void assignments of read-only temp char, with or without. Pass temp char. Error assignment read-only location temp char 0. Characters 1. Let me see. Error cannot convert constant char star 2 to constant char star for argument 2. Okay. Not sure here. So let me go here. Let's see, assignment. Hey, AK-47, KJP. We're trying to do simple stuff, but I'm failing miserably at it. Okay. Let's go here. Once we get this done, I can show you what we're trying to do, but for some reason, I'm just not able to get this stupid thing. No headphones, so can't hear. You don't have a headphone? Okay. All we need to do, let's see, temp char. Cannot convert constant char. Dagnabbit. Let me go up here. Let's go here, and let me just say, I don't know. Constant? Cannot convert char star. Constant char star. Make. Let's see. Second const. Make. Okay. Well, this one runs. It generates the image that we want. Okay, let's go from there. This is the messiest piece of code I think I've ever written. And I've written a lot of messy code. 1 second. Fine. It's not doing what we want at all, though. Shoot. Okay. Let's just keep that up for a second. Okay, so we have this being generated. And what do we need to do? We need to figure out why it's not writing anything. So let's see. Let's go ahead and output up here. std cout characters. No, I want to output temp char 0. 0. Then I want to end line. Okay, let's go ahead and go here. Let's make it one more time. See what we got. Just create a vector of std strings and put each of the characters in as a string and then pull them out using cstring for Cairo call. Yeah. Okay, here, let's do this. I'm just going to do it that way. Let me do this. Vector, character. Oh, but then I had a problem. I couldn't figure out how to get characters into strings. Okay, so let's do this. How to convert char to string. C++. How to convert character for one char to string. Okay. String sc. Let me see. String. And cout string. I can just do push back. Let's see what happens. So let's change this to string. Okay. So let's do pushback. Okay, let's see. Right here, let's go down here, and let's remove this guy for now. And what do I want? I want to do down here. What do I want? I want characters dot of I and characters of I. And let's see what happens. Make. Okay, so let me see. Invalid conversion. Let me see. 372. Text box. Invalid conversion from. Oh, I need .cstring. And down here .cstring. Make. Let's see. What's the problem now? 1 second. I'm working on it. Void request member C string, which is error request member C string. What? Which is a non-class type. So what you're saying is I need to do this. Let's see. 1 second. Make. Character constant too long for its type. Let's see. Narrowing conversion from int to character. Huh. Okay. Let me see. Character needs to be a vector again. It's just a single string at the moment. Should be okay. Oh, you want it to be a vector of strings? Oh, wait. I just want it to be a single string. So you want it to be a vector of strings. std vector of string. Make. Okay, key first. Okay, I didn't realize you wanted to be a vector of string. I thought you just wanted to be one string. Okay, so let's do key first. Let me see. X was only an example. Let's see. Key first is not a character literal. It is not. I don't get it. Let's go here. Let's write. And let's go make. Let me see. Characters of I. Temp character is equal to characters of I. Let me see. Let's go and comment this guy out. Let's make. Warning, unused variable temp character. That's fine. What's the issue? Error, no messaging function called for SD vector. Gosh. Okay. Let's go here. Make. Okay, well, it seems to run. Let's see what happens. Again, I apologize. This is probably super hard to follow. Mirage. Okay, let's see what happens. We are still not drawing anything. Okay. That's fine. So let me see. Why are we not drawing anything? Let's go through and let's not grow the circle. So let's go here. Let's remove this guy and this guy. And let's make. Because I think I know what happened. Okay, let's go mirage animation.gif. Okay, I know exactly what happened. Let's go here. Let's go to mirage, frames, image, 0, 0, why not? All the zeros. Okay, we go through. There are all the letters we want. Right there. However, they are not drawn consistently throughout. So what we need to do is the following. Are you drawing the text before the circles? No, I'm drawing the circles first. But what's happening is we're not drawing it on every frame. So what we need to do is draw it on every single frame. So we need to write a very quick function to go through and do that. So we need to stroke all of these guys. So let's go through, let's see, place text in a circle. Card set source. Let's see, we need to do 4. Let me see, grow circle. What we're gonna say is I int I equals animation.currentFrame, I less than num frames. I think it's plural. Plus plus I. We can go down here. And we're going to say Kairos stroke. These, instead of animation current frames, are just all going to be I. Oh, that was 0. That was nothing. Let's see. Characters of I. Oh, these are going to have to be J. Sorry about that. J. Let's go here. J and J. Your functions are too big. This is messy. Should have a draw node function. Yes, this is actually a draw node function. We have 2 different draw nodes functions. This is actually super simple in my opinion. So let's go here, change this to J. This will be shortened in a bit, but for now, we're going to leave it here to make sure it works. And here. Okay, let's write this. Let's make it. And let's see what happens. So temp char, of course, doesn't exist anymore, so we can get rid of that character. And we are drawing everything, so let's go here to Mirage Frames image.png. You're not drawing anything. Oh, I see. We want animation. Okay, so now we have the characters being drawn. That's perfectly fine. What we need to do is grow the circles again. Let's make it. Isn't the same function drawing all of them? I mean, yeah. 1 second. Let's go here. 1 second. And we're going to do Mirage animation.gif. And then it should be, yeah, we have all the characters being drawn, but they're not being drawn in the right place, and they're super small right now. So let's go and increase the text size. And then we need to drop them down a little bit in Y. So let's see. Where do we go to init? It's going to be init. Change text size. I'm going to double the text size. So let's change this to 20. And now we're going to go down to the draw external function. And let's see, draw external. And what do we want? Instead of, let's see, Y, we want a plus text box.height. Plus all nodes look the same to me. So you could have draw node and both draw internal and draw external call. Plus all nodes look the same to me. You could have draw node so that both draw internal and draw external call. So draw node would only handle drawing, and the other ones would handle looping and deciding what to draw where. Actually, all this is doing is deciding what to draw where, and I mean, I think this is fine. Let's go here. Let me do set number, and let me say from 369 to 378, we do the following. Okay, now we do set no number. Good, and that should be okay there. Now let's go ahead and write this. Let's make it one last time. And honestly, Untello, I'm not trying to dismiss the idea because it is a good idea and it needs to be done. However, it's kind of the end of the day for me and I need to get started, or rather it's 7 o'clock in the morning and that's typically the time that I end my stream. So I needed to kind of wrap it up. And so I'm going to take a look at this. We have all the characters being drawn. They're being drawn just fine. However, I don't like it very much. There's something we're missing here. So maybe if we put them in black, let's change the color to black. Let me see. Let's use 0, 0, 0. Let's make. Temp char doesn't exist, so let's go up here and remove temp char. And let's take a look at this. So I don't see here. Let me see. Yeah, okay. So it's much easier to see with black text on the letters, and that's good. So we can go from there. That's fine. Okay. So at this point, guys, we have all the letters being drawn on. They're not necessarily being drawn on the right spot. That's okay. We can fix that a little bit later. But this is okay. Like Untelo said, we can split this up into a little bit easier functions. Let me see. For example, placing text in a circle, this should be put into another function. I think this all should be kept into the same function though. I think this is, let me see. Auto key. Yeah, we could put it in different functions, but I think this is fine. I kind of like functions about this size. I don't like them smaller than that. Because then it's kind of hard to transverse a little bit. But anyway, it's totally up to you guys how you want to do it. For now, I'm going to go ahead and end the stream. We have all the characters being drawn inside of the tree. Everything's fine. Tomorrow, guys, I think what I'm going to do is take a step back from the Huffman trees and work on something else. Does your drawing program not have any layering? You might want to draw lines under the nodes. Wait, what do you mean? Does not have any layering. You might want to draw lines under the nodes. At this point, I have not implemented any layering. We can draw the lines under the nodes if we want. That is for later. It's something we could totally do, but we need to, or I need to do some thinking about how to do that. We could draw the lines under the nodes. I guess that's the next step. Anyway, guys, at this point, I think I'm going to go ahead and close the stream. Again, as I said yesterday, or as I said earlier today, I'm probably going to take time off from the Huffman stuff tomorrow and work on visualization of other things, just because I think it'd be super fun. We do not have layering, because again, this was home built. I will worry about the layering in a second. I guess we could put layers in there. I don't know, that's something to worry about later. But at this point, guys, I am going to go ahead and close the stream. So have a fantastic day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where either we continue working on the Huffman stuff, making this visualization just a little bit crisper, or we work on something else, and that other thing would be working on the next YouTube video, which will be related to determinants and things like that. I've got some cool visualizations I want to do there. Anyway, guys, thanks so much for watching. Have a fantastic day, night, afternoon, morning, evening, whatever time it has to be your time, and I'll see you next time. Bye, guys. Have a great day.